Okay, question number 2. This is the graph of displacement x against time t for an oscillating object. So you can see there's a graph over here. Use the graph to determine the following: A. The amplitude of the oscillations, the period, the frequency in hertz, the angular frequency in radians per second, and the maximum speed of the oscillating mass. Okay, so I'm going to copy this first. Okay, I will skip. Okay, so I'm going to copy this into this part. Okay, so now let's us see what we can do about this. Okay, so number 2, A is required to find the amplitude of the oscillation. So I call out my ball pen here. So the amplitude is from here until here. So A is very simple. The amplitude is 0.1 meter. So B's one is the period. So the period is the one complete oscillation. Either you can choose from this point up to this point, or this point up to this point. So these all are one complete oscillations. Okay, for the time needed for one complete oscillation. So the time here is actually 4.0 times 10 power negative 2 second. Now be careful of the units over here. It's negative 2. Okay, now C, the frequency. So whenever you get the period, so it's very easy to get back the frequency. So it is actually 25 hertz. Okay, now D, the question 1, the angular frequency. So the angular frequency would define as 2 by f. Omega equal to 2 by f. So the f that you got here is 25 hertz. So you eventually get 50 pi. Now the unit is radian over second. Okay, so and then lastly is the maximum speed of the oscillating mass. Okay, so we know that the speed is related to x omega. Okay, x omega. Now the question say the maximum. So the maximum means that the x will be at the maximum amplitude, where but omega will be the same throughout the oscillating. So you get the amplitude is here. This is the amplitude and this is the omega. So you times it 2, you will get 5 pi. Now be careful the unit. The unit will be meter over second. Or you can change it to 15.7 meter over second, where this is your V. Okay, where this is your V. Okay,